Let us start on the array based implementation of stack. So as we just saw, we have this stack as basically an array and a index top. Okay, so that's what we need to implement the stack. So let's create a struct to encapsulate everything which belongs to the stack data structure. So we will say struct stack, and we will put whatever it takes to make the stack, and we will call this struct stack is stack t, just a name type def. And what do we have in the stack? We have a array. We have a array with some max dimension, so maybe you call it max elements, and we have the top index. Top is the index of the topmost element. So that's our data type declaration of the stack. Okay, maybe we can define this max elements. Normally this hash define and struct stack will go in a header file, but I am putting it here as the initial thing. So that's the data type, and now let's visualize the push, pop, is empty, is full functions. Let's at least get the prototypes right, then we will fill in the content. So let's take them one at a time. So let's say we want to push. So what will be the prototype? We will need to pass the stack, and we will need to pass the element. I will call it lm, just like that. So what is the data type of lm? It's an integer. And what when I say stack, what can I pass? So ideally I should just pass a pointer to this structure. Okay, because these things will change, ARR will change, top will change, and anyway structures should not be passed by value. That's a costly thing. This is a big structure. The size of this structure is big because it has an array inside it and so on, and I want to change it also. So I will pass pointer to that structure and the element, and it will push. Okay, so maybe I can say it returns void. In some cases you can choose to return a success failure kind of status also, that were you able to push, because maybe the stack was full and you were unable to push. But I am initially keeping it void. You can choose to have it return underscore t, and return underscore t might be an int with some two values, success and failure, but anyway I am keeping it void for now. So, and let's consider pop. So I will what to say, I will just copy these and I will modify. So when I say pop, I am not giving any value. I am saying pop the topmost value, and the topmost value should be the return. Okay, should be the return. And if I am popping from a empty stack, then I should somehow indicate the error, maybe by giving a special value, or maybe by doing some error handling. So pop can be this prototype. Let me have the prototype of is empty and is full also. So I can have, again I can copy stuff, and let's say is empty. Again I will pass the stack as a pointer, because although is empty will never change the stack, we are not changing the array, we are not changing the top, but pass the pointer, it is much efficient. And if you are worried that we might accidentally change it, you can say it's a pointer to a constant stack. That's a good programming thing. We are saying that we are not going to modify the stack, we are just returning true false, and it might return a int true or false. So you can again define a return t and have feeds, success, failure, etc. But I'm just going to return an int, and 1 or 0 will be my result. And is full will be exactly the same thing. So is full will be exactly the same thing, that whether it is full or not. So that's the prototypes, and we will in the next video start filling code in it, and we'll try to run it.